All right, it seems that we are live. Hi, everyone. Welcome to the second Q&A with the LUKSO tech team. My name is Bianca. I'm head of DevRel at LUKSO, and today I have some very special guests, Yaman and Jean from the smart contracts team, our experts on the smart contract side. Thank you so much for joining us. Maybe before I go into the housekeeping, I would like to invite our community joining us from YouTube to drop in the chat what you're building in BuildUP number 2. I think we're all excited to see what projects will come out and how we can support you. Now, in terms of housekeeping that I was mentioning about, as usual, you will be able to find the recording for this session on the LUKSO YouTube. So in case you want to revisit a specific part or maybe the whole recording, you can do that even after this session. All right. Jean, Yaman, how are you today?
Doing good. How are you?
Good, good, good. I see already some questions coming in the chat, but waiting a bit more. Maybe let's start with some of the questions collecting on Discord, and then people have more time to drop their questions in the YouTube chat. The first one is, how do the new LSPs solve the approved transfer from problem? Who wants to take this one?
Yeah, maybe I can answer it. So the thing is, first, the approved transfer from problem, for anyone who doesn't know, it's basically with ERC20 or ERC7 when you want to approve a specific contract that do certain action, you will just specify its address and then you approve it. And then you need to do a second transaction in order to like notify the protocol contract that you approved him, so he can later do transfer from your account and like do whatever action with it, like swap or like minting some other stuff based on what you approved him. So how is this solved with the LSPs is that whenever you authorize, which is approve another contract or another address, this contract will be notified using the LSP1 universal receiver. So now protocols can automate the swap. Let's say, for example, if we took the example of a swap, you can directly authorize the swap contract, and in the same transaction, the swap can happen. So we are solving the approve and transfer from via the LSP1 notification. In this way, you don't need two transactions, you just need the authorized operator transaction, and then the token, the swap contract, our example, should handle the way it uses the authorization logic. That should be it.
Jean, is there something else you would like to add, or are we good to move to the next question?
Yeah, I think it's pretty much of a. Yeah, I think Yaman boiled down everything. Yeah, basically with this external call, you can. You don't need to. You don't need to have two transactions starting from the same caller, like one transaction where the contract approved and the second transaction solidity will be a bit below in the source code. You can have like all the round trip, and you have also the ability, like when it comes to UP, to have the addresses that you want to approve. To instead of using approval, you give permissions through the key manager, and these addresses can interact through your UP. So in the end, it's the same contract that does everything. There's actually no need for approval. It's just wrapped up behind the scene with the permission management on specific addresses. It's like also another way to reapproach the approved transfer from problem, I would say.
Thank you both. Our next question taps a bit into this, but it's still slightly different. So when does it make sense to have something like an LSP1 delegate contract?
Sorry, could you repeat the question?
Sure. When does it make sense to have something like an LSP1 delegate contract?
Oh, well, I mean, there is a lot of there's really a lot of use case that you can think of. It's basically when you want any form of automation happening as soon as an event occur. You can think of it as like really pretty much anything. To give practical example, that can be things like the default behavior that we have built is registering the assets that you received under your LSP5 received assets. So that could be things similar, like when you get notified about something, let's say a DApp notify you that you have reached that someone followed you on a decentralized social media account, you can write a note in your storage. Or you can have things like when you receive a specific token, let's say if I receive, for instance, like if I will receive USDC, you can say, okay, take a percentage and put that into another account, a vault, like a saving pot. Or if you receive like things like valuable NFTs, instead of storing them into your account, you can do the same thing as you will do in a real life, like people who have like valuable assets, they store them into storage safeguarding solutions. So same, you store these valuable NFTs into your digital vaults. You can have things like automated trading, or you can have things like notifying other users that you follow. So it's pretty much anything really. Like I give here a few examples, but you can think of it as really like any form of automation that you want to happen for, like let's say any social use case or financial use case. Like think of anything in the real life that happen automatically. Like for instance, like in banking, there's new thing of save the change. It's something that the LSP1 delegate could do. For instance, you could save the change round and put the rounding into a jar. So this kind of example.
Yeah, probably I can add here. So the question was probably when does it make sense to have a universal receiver delegate? So the starting question should be, when does it make sense to be notified? So for instance, in the token, like when you receive a token, it makes sense to be notified, like notify the sender and the recipient. And now since you're notified, you can add whatever universal receiver delegate to react on the call. So you can add a universal receiver delegate that transfer the token to a different address, a universal receiver delegate that reverts, a universal receiver delegate that probably split the percentage in some way. And this is just one thing related to the token. So other protocols or other contracts that notify you are vaults. So when you receive a vault, you will also be notified, and then your universal receiver delegate can contain a logic that reacts on it. And probably later, there will be other protocols and apps that wants to notify you about certain action. Probably Jean also does mention the idea of royalty. When you will get a royalty, the protocol can inform you through the LSP1, and then you decide what universal receiver delegate you will set that react in a certain way. So it's up to each protocol and the app to notify you, and then it's your decision to put whatever universal receiver delegate so that you can react in a way that you want. Yeah, that's it.
So a lot of use cases for the LSP1. We have some questions coming from YouTube this time. The first one is, I have an app and I want for my users to have a user account, not their personal account. Does it make sense to have a single key manager to all my accounts?
I'm reading the question again, so I can answer properly.
Yeah, but if I understand, no, technically that you can, because the key manager is mapped to a single UP. Yeah, unless I will have to read the question on YouTube. Haven't it open, but yeah, technically key manager is mapped to a specific account. You cannot have a key manager that is set for multiple to control multiple accounts. That could come in the future, but at the moment it's not set up like that. However, you can have a controller that can control multiple universal profiles. You can have the other way around.
Yeah, to stay like compatible now with like what LUKSO have, which is one key manager to one profile. What you can do is like build your app in a certain way that maybe all the user account are specific sub accounts that a universal profile control. And then you can, within your main key manager, decide how to split permission to control these sub accounts, which can be vaults or like accounts or whatever like you want. So yeah, but I wouldn't say that having now like a one single key manager for all the users is the best.
So it basically depends on the use case. Our next question is the following. Is it possible to allow transfers for LSP7 or LSP8 if and only if you initiated the interaction, for example, through an NFT mint or a swap, but not if someone else is sending them to you? And the same person is asking if this is possible, how would you go for implementing it?
Yeah, I think, yeah, this is like the universal receiver delegate are smart contract logic that needs to be implemented. Obviously, for normal users, it will be like later a website that you choose how to react on it. But like first, it needs to be built by smart contract developer. So I'm trying to simulate this in my mind to see how it works. But technically, yeah, you can probably. You can know because like whenever the mint is happening in the token contract, your universal profile will be notified with who's calling the mint function, which is like the person initiating the transaction. So probably you can track that in the data that is being sent and just say if the operator is this person, like operator, the person performing the logic is this person, then allow it. If it's, which is your address. If it's a different address, deny it. But I need to double check in the contract code, in the token contract. But probably it's possible, I'd say.
We can follow up on this one in Discord, just to be super sure. All right, our next question. Would the VRF for LUKSO be useful? I assume this refers to Chainlink VRF for generating random numbers.
Sorry, what was the question?
Would the VRF for LUKSO be useful?
I mean, like the VRF would be something that protocol use and like developers, but I would consider that an integration that is useful. obviously, because like current, I don't know if there's a VRF on LUKSO yet, but I would say it's a good integration, yeah.
Our next question is, could you go a bit over the differences of LSP7 and ERC20, please, and what parts need to be implemented differently?
Yep. So there is a page in the docs under the contract section, and if you click on digital assets token NFT, where there is a bit of comparison, mainly at the API level of a function. So the main difference is that, first of all, transferring as a token owner or an operator is done with the same function compared to ERC20. So with ERC20, if you want to transfer assets to someone, like if I own asset, I want to transfer them to Yamen, I call the transfer function. If I want to authorize Bianca to transfer some of my assets on my behalf, she has to call the transfer from. With LSP7, it's just the same function. It's just one single function with from to amount. And this is just used as the standard basically function for doing all of these interactions. So that's one of the first difference. And the same for ERC721. With ERC721, it's even easier because you have transfer from and safe transfer from, and you have two variants of safe transfer from, one with data, one without. And basically, with LSP8, you have the data, you have the same function. It's a single function transfer. And these functions have almost the same signature. It's like 5 parameters, except that it's an amount for LSP7, it's a token ID for LSP8. So basically, you can think of it like you don't have to learn how to interact with like how to interact with ERC721 and how to interact with ERC20. You just have to learn how to interact with the LSP7 and 8. They have they do the same thing. They are transferred the same way. It's just the amount or token ID, that parameter that changes. That's for the transferring. For authorizing, it's a bit the same as the others. It's just you have the function is just authorize operator instead of approve. So that's mainly if you are building like an application that you want to use LSP7, that's the first and you want to use LSP7 or 8, that's the main thing that you will look into compared to ERC20. And I will say the second big thing, which is more like high level in terms of design, is that when you are using LSP7 and LSP8, it's what we were talking about, the universal receiver, but Yamen was explaining, is that you have to build your application. You have to think of the logic of your application a bit differently. You are it's a bit more open and flexible because you have a notification system with the hooks that you can leverage to create a round trip, or you can create like a notification system where, let's say, for instance, you make a swap, and when the money goes into the pool and you get back the other assets that you exchanges for, then you can, in this because you have this external call happening, you can automate that instead of before you had to do this whole logic of transfer from. So I think in terms of API, it's a bit easier because it's just one function for both. In terms of designing your application, it's just you can approach the task differently than what you will do instead of ERC20 and 721. That's what I would really recommend, to not like to try. You can try to do the same thing that you will do with 20 and 721, but then you can try to look at the specs and API and the core functionality of the token to do things a bit differently.
Yeah, and I would add just a few simple points. So Jean summarized it in terms of like the API and also mentioned in terms like standard differences. There is also a thing related to the metadata. So all of this is mentioned, as Jean said, in the contracts API section for the differences with the API, and like for differences in terms of like design, it's in the standard section on the docs. You can find more information there, but in short, one of the other differences is that ERC20 have limited metadata, so you just have access to the name, symbol, and the decimals, and you don't have any other information. But with LSP7, you can basically write anything to the asset. You can just mention any information in the token contract storage. So where is this relevant is that, for instance, you can mention the creators, which can later lead to have the asset verified in terms of like authenticity. So like the creator of this asset can reference the asset and the asset can reference its creator, and then you have verified authenticity. So this is one of the main use of the storage, but technically you can write anything else. You can reference also the community behind it. You can like store addresses that should have royalties, basically anything. And also one other difference is that there is handling when you transfer. So when you transfer, you can specify whether the expected account is an EOA. It's not about like specifying, but like you can, you have a force parameter. If the recipient is a smart contract account, you don't need to force it. But like if the recipient is an EOA, you need to force it, because why we did this is because of security. Like there's a lot of people who complain that they lost because of like putting the wrong address when they transfer. So since we expect a lot of people to have a smart contract account, it's not that possible to have a mistake and then lead to an address that is also a smart contract account. So always have the force parameter as false, and then if you have like a typo in your address and then this lead to an EOA, the transfer will fail and you will not lose your tokens. So that's it's more explained in the docs. It's like about forcing the transfer, and yeah.
Personally, I'm also happy that we got this question, because I think this is great to kind of remind people that it's important. And one of the criteria for the hackathon is to integrate with the LUKSO standard proposal. So if you're building something, always having in mind how to integrate with the LUKSO standards. Now, we have one last question left so far. How does verifying signatures work for universal profiles?
Yeah, so technically the universal profile is a smart contract account, so it cannot sign like an externally owned account. There is a standard called 1271, which standardizes that in order to verify a signature for a smart contract account, they should implement a specific function. So the universal profile is compatible with this standard, and basically what the function does is that it delegates the verification to the owner if the owner is a contract, and if the owner is an EOA, it checks if the signature is valid according to this EOA. So in normal cases, like we have currently, the universal profile is owned by a key manager, and the key manager is obviously can be controlled like by different controllers. So how we do it is that the isValid signature function will return true if like the EOA that signed this message was a controller that have the signed permission. If this controller does not have the signed permission, even if the signature is valid for this EOA, it will not be valid for the profile. So it's essential to give the EOA the permission to sign, which is like standardized, the sign permission. in order to make his signature valid for the whole profile. But like if it was other cases when the profile was owned by a different contract, it's up to the contract to implement whatever logic to verify signature. But currently with our stack, which is a universal profile owned by a key manager, the controller should have the signed permission in order to make his signature represent the whole signature of the profile.
We have one additional question coming on YouTube. Do I have a preferred method for storing private user data in a DApp? IPFS is used usually in the tutorials, but it is not really easy for onboarding.
Yeah, I can add a bit onto that. So technically, it's not really specified in the specs, but IPFS is one of the way you can store data for a UP. The reason IPFS is used is because there is the JSON URL is to do content-based addressing, meaning that the actual state of the data and like the pointer in from UP to your data is based on its content, and not based on where it's located. But you can technically you could technically have a UP that has all its information stored into like let's say a private server. So let's say a basic example is that you have your own private server at home with your own storage. You have a specific restricted ports, and you have all of the IP address encrypted. You can technically store this location on your data key value store. So you could store the data encrypted inside of the key value store, and you can have let's say your application that reads the data from a specific data key with the encrypted data, and only the user who has the private key behind on its local machine can then decrypt it and then fetch the data locally. So you can have these kind of schemes that you can design, but you can store the encrypted data inside the profile, or the encrypted pointer to the data. For instance, if you don't want to reveal what's the IP address of a private server. So that's kind of example of how things could be designed. But I will still say that although IPFS is not the most user-friendly for onboarding, I will argue because with the tooling that we have and the DApps, how they display your data, right now they display the data from fetch and retrieve from IPFS. So if you use an alternative storage solution, you will have to build all of that, all the decoding and displaying. So which actually it's a bit more work on the developer side. So like the user don't really care of how it's stored and how it's done. It's more of an application that should be, I think, adapted to that. So I think this is the trade-off. It is like one is more user-friendly, but it requires more work on the development side. The other is more is less user-friendly, like IPFS, but on the developer side, it's much easier to integrate. Yeah, and that would be pretty much my answer to that. Yeah, I hope that answered the question.
Thank you, Jean. Yeah, actually, we got a reply while you were presenting that this is also what Laszlo was thinking. There is one additional question. What happens after the hackathon and the products build and the teams that participated? I can give a few thoughts here. So ideally, the hackathon is just the starting point for those projects, and we're looking for projects that have the potential to grow and to mature for the LUKSO ecosystem. them. And of course, we're very happy to support further those projects. So take it as an opportunity to come up with a cool idea, and you don't know where this can lead you. All right. Looks like we don't have any more questions for the sessions today. Thank you so much to Sean and Yaman for their answers, and to people watching on YouTube and asking their questions. Usually, you're going to find this, as discussed, you're going to find this on our YouTube. And as usually, if you have further questions, you have the Hacker Discussion channel on Discord, where they're available to answer any questions. And see you next Wednesday for the third Q&A with the LUKSO Tech team.
Thank you. See
Thank
you.
you.
Everyone.